Welcome to the deep dive. Today, we're jumping into a stack of sources all about Google Apps Script and its integrated development environment, the IDE.
That's right. We've gathered, articles and notes to really give you a shortcut to understanding this tool. It's become, well, a real powerhouse for anyone looking to make their Google Workspace apps work harder for them.
And our mission today is basically to cut through the jargon, show you how Apps Script can help automate tasks, simplify workflows, and just generally extend what's possible within Gmail, Sheets, Docs, all the usual suspects.
Think of it like unlocking the hidden potential in the tools you probably use every single day.
Exactly, even if you don't have, a full-on programming degree.
Yeah, definitely. We're going to unpack what it is, how you get started, the key features you'll use for building things.
And importantly, how to figure out what went wrong when, let's be honest, things inevitably break sometimes.
Right, troubleshooting. And also how to manage projects, especially if you're working with other people.
So let's dive right in. Okay, first things first. What exactly is Google Apps Script?
The sources describe it as a rapid application development platform, RAD, and sometimes low code.
Yeah, essentially it's Google's own tool for making its apps talk to each other and do more. It's built specifically, to integrate with things like Gmail, Calendar, Drive, Sheets, Forms.
It's core workspace stuff.
Exactly. The whole point is automating those repetitive tasks, streamlining admin work, or adding custom features that just aren't there out of the box.
And it uses JavaScript, right? Which is a pretty common language for web stuff.
Right, yeah. So if you've ever looked at website code, some parts might look familiar. And that JavaScript foundation gives you access to these really rich, built-in libraries for all those workspace apps.
Okay.
But here's where it gets really powerful. According to the sources, it integrates natively with over 100 other Google services.
100? Wow. Like what?
We're talking things like Google Analytics, Maps, YouTube, even BigQuery. If you're dealing with huge data sets, it just opens up this massive range of possibilities. Okay, 100 services is definitely significant. And a key point the sources really emphasize is its accessibility. Anyone with a standard Gmail account can use it.
Yeah, and this seems pretty deliberate on Google's part. By making it browser-based, no installation needed, they're positioning it as a tool for widespread business enablement.
Empowering citizen developers, as they call them.
Exactly. Folks who know their business needs inside out but aren't necessarily pro coders, they can now build their own solutions.
Which brings us to the IDE itself, the integrated development environment. That's like the workshop where you build these scripts.
Precisely. And it's entirely cloud-hosted. It lives right in your browser.
No local setup needed at all.
None. Your code saves automatically to Google Drive, and when you run it, it actually executes on Google servers, not your machine.
And the IDE supports JavaScript for the logic, but also HTML and CSS for user interface.
Right. If you need to build, say, a custom web app, or maybe a pop-up dialog box, or even those side panels you see in Docs or Sheets sometimes.
The sources also mentioned some nice recent updates to the IDE itself, making it easier to code.
Yes, they've been steadily adding features you'd normally expect in more traditional desktop development tools.
Like auto-completion.
Yeah, rich auto-completion to help you type code faster and avoid mistakes. There's also a pretty powerful command palette. You hit F1 for quick actions and navigation.
Oh, handy.
And even a high-contrast dark mode, which is always popular for coding. They're clearly trying to make that browser environment as productive as possible.
Okay, so it's accessible, powerful, cloud-based. Sounds great. But the sources also point out that this cloud-native approach has, well, trade-offs.
That's a really crucial insight, yeah. While the browser access is a huge strength, it does come with certain limitations.
Like what?
Well, for instance, scripts have execution time limits. They can't just run forever. There might be restrictions on accessing every single Google service or API, though the main ones are covered. And integrating with traditional software development workflows, like using Git for version control, that can be a bit tricky.
And the fact that tools like Clasp even exist is kind of telling, isn't it, about those trade-offs?
Absolutely. Clasp is this command line tool that lets you download your Apps Script projects and work on them locally. Its popularity really shows that for more complex projects or team projects, developers need ways to bridge that gap between the simple browser IDE and, more robust local workflows and version control systems like Git.
So Google kind of acknowledges this need by supporting Clasp.
It seems that way, yeah.
Okay, so you're convinced. You want to try automating something. How do you actually get to this Apps Script IDE?
There are basically two main ways, according to the material we looked at. The most common, probably, if you want to add automation to a specific Google Doc or sheet or form, is you open that file
Right.
and you go to the extensions menu, then select Apps Script.
And that creates what they call a container-bound script linked to that file.
Exactly. That script project is now permanently attached to that specific document. It's perfect for adding custom menus to that sheet or creating a special function that only works in that sheet or automating something based on that form's responses.
Got it. So it kind of lives inside the document. What's the other way?
You can go directly to the Apps Script dashboard. The address is script.google.com, and this is where you create standalone projects.
So scripts that aren't tied to any single document.
Right. These are great for more general utility scripts, maybe things that run on a schedule, or for building completely separate web applications that aren't directly tied to one file.
And either way you start, you usually just get a default code file.
Yeah, typically a code.gs file shows up, and you can rename the project from untitled project to something, more meaningful.
Now, here's something the sources highlighted that I found really interesting, maybe a bit surprising. Since it's all browser-based, you'd think you could just pull it up on your phone for a quick edit, right?
You would think so, but the sources are very, very clear on this. The IDE is explicitly not designed for mobile browsers. Trying to use it on a phone is, frankly, a pretty miserable experience.
Miserable how? What kind of problems?
Oh, significant ones. You might get redirected to the mobile drive or Sheets app, which doesn't have the script editor. Even if you force the desktop view, the code interface can be really erratic, hard to tap on things accurately, and the keyboard constantly popping up can make it almost impossible to see the code you're trying to edit.
So basically, unusable for real work.
Pretty much. The sources describe it as having substantial hurdles on Chrome for Android and maybe barely doable for super minor edits on Firefox Mobile. It really underlines that Google sees this as a desktop tool.
Designed for a proper keyboard and screen.
Exactly.
Yeah.
Which makes sense for coding. However, the sources do point out one surprising, almost critical use case for mobile access, despite all these problems.
Oh. What's that?
Emergency admin tasks.
Right.
Like, if a really critical script breaks overnight and you don't have your laptop, being able to wrestle with the mobile interface, however painful it is, just to manually trigger a crucial function or quickly disable a faulty trigger that could be a lifesaver.
Ah, I see. So it's like a last resort emergency override, not a place to actually write code.
Precisely. It's useful purely out of necessity in those rare, urgent situations.
That's fascinating. It almost feels like there should be a separate, simplified mobile interface just for monitoring and basic admin tasks.
That's a great point. The current situation really only works in a pinch.
Okay, so you've managed to access the IDE on your desktop. What are the core tools inside that browser environment for actually writing the scripts?
Well, the heart of it is obviously the code editor. You're writing in modern JavaScript, and as we mentioned, you can also create HTML and CSS files if you're building any kind of user interface, web apps, dialogues, sidebars, that kind of thing.
And there are features to make coding easier, you said.
Yeah, features designed for productivity. That rich autocompletion is a big one. It suggests code as you type, which speeds things up and cuts down on typos.
Saves looking things up constantly.
Exactly. And that F1 command palette gives you quick access to lots of common actions without needing menus. Plus, things like the dark mode just make it more comfortable for longer sessions. They're definitely trying to bring some of that professional IDE feel into the browser.
The sources mentioned a best practice for UI development, something about separating code.
Yes, just for readability and keeping things organized. Even though your client-side JavaScript often goes inside .html files in Apps Script, it's generally good practice to clearly separate the HTML structure, the CSS styling, and the JavaScript logic within that file, or even use separate files if the UI gets complex.
And managing those different files within a project, how does that work?
An Apps Script project is essentially just a collection of files. You'll have .gs files for your server-side code and .html files for UI. The IDE handles one project per browser tab.
And adding new files is easy.
Yeah, there's usually a plus icon or something similar near the file list, letting you add a new .gs file or an .html file.
And one thing to be careful about.
File deletion is irreversible. Once you delete a file from the editor, it's gone from that version of the project, so be sure.
Okay. And there's also this special file, appscript.json, the manifest file.
Right. Think of that as the script's configuration file or its rulebook. It controls really important settings.
Like permissions.
Exactly. It defines which Google services your script needs permission to access. They call these scopes. It also handles other settings related to how the script behaves, add-on configurations, deployment settings. You usually don't need to touch it directly, but you can enable editing it in the project settings if you need that fine-grained control.
Speaking of project settings, what else is important there?
Well, you can set the project's time zone, which affects how triggers run, though you can override it in code. But probably the most crucial setting, especially for more serious scripts, is the ability to link your Apps Script project to a standard Google Cloud Platform project, a GCP project.
Okay, and why is linking to your own GCP project so important? The sources seem to stress this.
Yeah, it's a big deal for building anything that needs to be reliable, like production applications. While AppScript works fine standalone, linking it to your own user-managed GCP project unlocks much more powerful services.
Primarily logging and error reporting.
Those are the big ones. Cloud logging gives you much more robust, searchable, filterable logs than the basic logger.log. And cloud error reporting automatically captures errors when your script fails. If you have an important script running automatically, you need this kind of monitoring to know when things go wrong and diagnose why.
So it's about moving beyond just development testing to actual production monitoring.
Absolutely. The basic logging is fine when you're actively coding, but it's not enough for unattended scripts. Linking to GCP also potentially gives you access to a much wider range of Google Cloud APIs if your script needs advanced capabilities like, say, machine learning or connecting to Cloud SQL databases.
Gotcha. And deployment settings are in there too, for making it a web app or an add-on.
Yep, that's where you manage how your script is published and made available to others or runs as a service.
All right, debugging and troubleshooting. Always fun. What tools does the Apps Script IDE provide when your code inevitably doesn't do what you expected?
You've got a few layers. For quick checks while you're coding, you can sprinkle logger.log or the newer console.log statements in your code. Their output shows up right there in the editor's execution log panel.
Like basic print debugging.
Exactly. Simple and effective for quick checks. But again, for anything more serious or running unattended, cloud logging via that GCP link is the way to go. It's much better for digging through logs from multiple runs.
And what about actual errors, when the script just stops?
That's where cloud error reporting, if you've linked GCP, really shines. It automatically captures those runtime exceptions, the errors that crash your script. It groups similar errors, tells you how often they happen, which helps you prioritize fixes without manually sifting through log files.
And there are also the general execution logs.
Yes, accessible right from the IDE, usually via a little play icon or something similar in the sidebar. This gives you a history list of every single time your script ran, whether you triggered it manually or it ran on a schedule.
What does it show?
It shows the start time, duration, whether it completed successfully or failed, and it includes any logs, basic or cloud logs, generated during that specific run. It's like your script's flight recorder, invaluable for figuring out intermittent problems by looking back at past runs.
Okay, and then there's the interactive debugger. That sounds pretty powerful.
It really is. The debugger lets you run your script step by step in a controlled way. You set breakpoints, you just click in the margin next to a line number, and the script will pause execution when it reaches that line.
And when it's paused?
You can see the current values of all your variables at that exact moment in time.
So you can inspect the state without having to add a million log statements?
Precisely. It gives you this X-ray vision into what your script is actually doing, which is incredibly helpful for understanding why it's behaving unexpectedly, especially when it's processing data from, say, a sheet or an external source.
And you can step through the code.
Yep. You have controls like step in to dive into a function call on the current line, step over to just execute the current line and move to the next, and step out to finish the current function and return to where it was called. It lets you walk through the logic methodically.
The sources did mention one specific kind of niche limitation with the debugger.
Yeah, it's a bit technical. If you happen to be debugging JavaScript code that was generated dynamically, like using the evil function to build and run code on the fly, the debugger might show a message like, source code for the current line is not available.
So it gets confused.
It loses the direct visual link to the original source line in that specific case. The debugging continues. You can still see variables and step, but you just don't see the highlight on the code line itself. It's a minor constraint for most people, but worth knowing if you use those advanced dynamic patterns.
Makes sense.
Hmm.
What about just common errors people run into and basic troubleshooting tips?
Well, the error messages themselves are your first clue. They usually tell you if it's a syntax error, something wrong with how you wrote the code, which usually shows up when you try to save.
Or a runtime error?
Right, an error that happens while the script is actually running. The message often gives you a line number too. Common causes for runtime errors, according to the sources, can be anything from temporary hiccups on Google servers.
Which happens.
It does. Or, just plain bugs in your script's logic, or occasionally some unexpected behavior within Apps Script itself.
Authorization issues seem like a recurring theme in the sources.
Oh, yeah. Very common. A classic one is setting up a time-driven trigger like run this every hour before you've manually run the script at least once to grant it permission to access, say, your Gmail or your Sheets.
So the trigger fires, but the script doesn't have permission yet.
Exactly. It fails silently or with an authorization error. The fix is usually simple. Run the function manually once from the editor to go through the authorization prompts. Or sometimes removing the trigger and re-adding it after authorizing helps.
What else? Library problems.
Yeah, if you're using external libraries, sometimes they can cause issues if they're outdated or have bugs. Solutions there might involve updating the library, removing it, or sometimes even just copying the specific code you need from the library directly into your own project.
And multi-login issues, being signed into multiple Google accounts.
Yes, that can definitely trip things up, especially with web apps or custom functions in Sheets. Apps Script can get confused about which user's context or data to use.
The standard fix being,
Log out of all your other Google accounts in that browser session, or just use an incognito window where you're only logged into the one relevant account. Usually sorts it out.
okay, shifting gears a bit, let's talk project management and collaboration. How does Apps Script handle this, especially if you're working in a team?
Well, this comes back to that key distinction we talked about earlier, standalone versus container-bound projects.
Right. Standalone are independent, container-bound, live, inside a specific doc or sheet.
Exactly. And how you manage them, especially regarding sharing and ownership, is fundamentally different.
How so?
Standalone projects are managed from the Apps Script dashboard, script.google.com. You create them there, you delete them there. Container-bound projects, though, they inherit their permissions directly from the host document.
So if I share editor access to my Google Sheet with you,
Then I automatically get editor access to any Apps Script project bound to that sheet.
wow, okay, that's a really important point for collaboration.
It is. And deleting a container-bound script is also different. It's irreversible, and only the actual owner of the host document can do it via the script editor's overview section, not just anyone with edit access.
Got it. So for actual team collaboration and managing ownership long-term, the sources point towards using shared drives, what used to be team drives.
Yes, that seems to be Google's recommended native solution within Workspace.
And the main benefit for scripts in a shared drive is?
Collective ownership. This is critical. When a script project lives in a shared drive, it's owned by the team or the group, not by a single individual.
So if the person who created it leaves the company.
The script doesn't become orphaned or inaccessible. It still belongs to the shared drive, and the team retains control. That's huge for business continuity.
Makes sense. And shared drives also help with just general collaboration on the script files.
Yeah, and they make it easier to move files between different Google domains, which can be useful if you're doing work for external clients, for example.
And what permissions do collaborators get within a shared drive?
Anyone who has editor access to the shared drive itself can generally create, view, edit, run, manage versions, and even publish add-ons for any script projects stored within that drive. People with full access can also delete scripts or move them out.
Are there any catches or limitations with using shared drives for scripts?
There's one really important one highlighted in the sources related to deployment. If you're deploying a script as a web application or using the Apps Script API,
Okay.
the deployment must be created or updated by a user account that belongs to the same domain as the shared drive itself.
So if you move a script in a shared drive from, say, your company domain to a client's domain, any existing web app deployments might break.
Exactly. Transferring ownership that way across domains can break deployments, and you might have to move the script back to the original domain to fix or update the deployment.
That's a key constraint, especially for larger organizations or cross-company collaboration. It really positions shared drives as a powerful solution, but primarily within a single domain for deployment purposes.
Right. The sources suggest Google views shared drives as a kind of native, cloud-based DevOps-like approach for team ownership and basic collaboration within Workspace. It reduces the immediate need for external tools like Git for simple ownership management, but it definitely has boundaries, especially that cross-domain deployment one.
And this neatly brings us back to that challenge with traditional version control, like Git that we touched on earlier. The browser IDE just doesn't integrate easily.
No, it makes proper change, tracking, branching, merging, all that standard stuff quite difficult for larger or team-based projects, and that's exactly why the sources consistently recommend Clasp.
Clasp again. It really seems like the essential tool for serious app script development.
It effectively bridges that gap. Clasp is that command line tool that lets you pull your Apps Script project code down to your local computer.
So you can work on it locally.
Exactly. You can use your favorite code editor, you can integrate it with Git for proper version control, you can write automated tests, use linters, all your familiar local development tools and workflows.
And then push the changes back up.
Yep, you can push your local changes back to the Apps Script project in the cloud, and you can even manage deployments directly from the command line using Clasp. It also provides a way to easily export or back up your project files locally.
So for anything beyond simple scripts or for team projects, it really becomes a hybrid workflow. Maybe quick edits in the browser, but serious development and version control done locally via Clasp.
That seems to be the key takeaway. Clasp enables this necessary two-tiered experience. The simple browser IDE is great for accessibility and citizen developers, but Clasp provides the path to robust professional development practices for more complex projects.
Okay, finally, let's talk about the really exciting part. What can you actually do with all this? The integration capabilities seem like the absolute core strength here.
They really are. I mean, the fundamental design purpose of AppScript is that seamless, deep integration with Google Workspace. The built-in services give you incredibly powerful native access to Gmail, Calendar, Drive, Docs, Sheets, Forms.
So give us some concrete examples. What kind of automations are we talking about?
Oh, the possibilities are vast. You can create custom menus or dialog boxes or sidebars right inside Docs or Sheets or Forms to trigger your scripts.
Like adding your own buttons.
Exactly. You can write your own custom functions in Google Sheets, essentially creating your own spreadsheet formulas.
Powerful.
You can totally automate email workflows in Gmail, automatically labeling emails, archiving them, forwarding them based on content, even scheduling emails to be sent at a later time.
What about Calendar or Drive?
Yep, create calendar events automatically from data in a sheet, maybe. Or programmatically organize files in Google Drive based on their names or dates or content. And you can even build full-blown add-ons that other people can install from the Google Workspace marketplace.
Now, you can build quite sophisticated user interfaces and deploy them widely.
You definitely can. And it goes way beyond just those core Workspace apps. Remember the 100+ other Google services? You could pull real-time data from Google Analytics directly into a sheet for reporting. Automate tasks related to your YouTube channel. Or, a really cool example from the sources, run sentiment analysis on text in a Google Doc using the Cloud Natural Language API, all orchestrated by Apps Script.
Wow.
And linking to your own GCP project, as we discussed, opens the door even wider to things like using machine learning models or connecting to cloud databases.
Okay, but what about connecting to things outside the Google ecosystem, like other business software you might use?
That's another major strength. AppScript makes it relatively straightforward to connect to external third-party APIs and web services.
So it can act as a bridge between Google Workspace and, say, your CRM like Salesforce or communication tools like Slack.
Precisely. It can become this central automation hub connecting data and workflows between Google Workspace and all sorts of external business systems, Salesforce, Slack, Trello, HubSpot, Dropbox, MailChimp.
Wow.
The list goes on. There are even add-ons built with AppScript specifically for these integrations.
And how does it technically make those connections?
The key service for that is called URLFetch. It's built into AppScript and lets your script make standard HTTP requests, GET, POST, etc., to external websites or APIs to send or retrieve data.
So that's the mechanism for talking to the outside world.
Exactly. Though the sources do offer a gentle reminder to be efficient, try to minimize the number of external calls your script makes, as each one adds latency and contributes to those execution time limits we mentioned earlier.
Right. Performance matters. So as you can see, really diving into Google Apps Script and its IDE reveals this, well, incredibly powerful tool. It's specifically designed to make the whole Google Workspace ecosystem much more flexible and automatable for you.
Yeah, its absolute core strength is that accessibility, isn't it? That browser-based, low-code approach really does lower the barrier to entry. It empowers so many different people, those citizen developers, to build solutions tailored to their specific needs.
But as we've definitely explored, that cloud-native design comes with those specific trade-offs you just have to understand. Things like the execution limits and the inherent challenges with integrating traditional version control systems.
Right. And what's really fascinating looking at the sources is Google's evolving strategy here by actively supporting tools like Clasp and encouraging integration with the broader Google Cloud platform. They seem to be deliberately bridging that gap.
Between the simple browser tool and the needs of more complex, maybe production-ready projects and professional workflows.
Exactly. It's not a static thing. They're constantly refining it, adding features like better auto-completion and the command palette to make that in-browser development experience smoother and more capable over time.
So ultimately, Apps Script isn't just about automating one little task here or there. It really feels like it facilitates broader digital transformation by acting as this sort of connective tissue,
Yeah, automating and integrating across so many different services, both inside Google Workspace and connecting out to external systems as well.
which really leads to a final important question for you, the listener. Considering its unique strengths, its accessibility, but also its limitations, where might Google Apps Script fit into your own workflow or your own projects?
Thanks for joining us on this deep dive into your source material.